Hi guys, and welcome to another lesson where we are going to talk about working on hardware with Python. So there has been an upsurge of hobbyists interested in programming physical devices in recent years. Low-cost, highly flexible products such as the Arduino microcontroller card and the Raspberry Pi single-board computer, which is also short for SBC, have become available at very low cost. Python is well suited to programming such devices, and several libraries exist to assist in the process. Indeed, Python is one of the recommended languages for Raspberry Pi. It is not necessary to spend money on hardware to connect Python to the outside world. Most computers still have a serial port running the RS-232 protocol, and it is possible to connect that to various peripheral devices and access them using Python. Similarly, the MIDI interface can be used to access musical instruments, and even the ubiquitous USB interface can be manipulated with the right modules in place. As is the case in any kind of integration, you need to understand both ends of the connection. If you are not familiar with the physical devices to which you want to connect, you will struggle. The first step in integrating Python with anything is to first find out how the target device interacts with the world. Only then will the libraries discussed in the following section become useful to you. So let's talk about serial options. You can access the RS-232 communication port on a computer, or indeed any other serial port, including old-style PS2 mice or pens, using the serial module that is also made available by the PySerial project, which has its homepage at pyserial.sourceforge.net. Just Google it. Comprehensive documentation and examples are included on the website. The module provides support for several OSs, including Windows and Linux, as well as Jython and IronPython. It can be installed from PyP or as a Linux package in most distributions, or for Windows as a binary installer. It works with both Python version 2 and 3. The PyUSB library is available for USB access. It is written in Python using C types under the covers to access the low-level code. You can find PyUSB at GitHub. So the website is a tad sparse, but it includes a tutorial with several examples. It is assumed that you already understand how USB interfaces function. PyUSB is available from the GitHub repository, but it is easier to install via the PyP. And then you have Raspberry Pi. The Raspberry Pi is a single board computer about the size of a credit card and sold at very low cost. It was originally intended to encourage interest in computing technology and programming. It has been hugely successful not only in its original objective but also as a hobbyist tool. Many owners have capitalized on its small size and built the computer into small physical enclosures for applications such as weather monitoring, security systems, robotics experiments, and vehicle control. The Raspberry Pi runs various distributions of Linux, the defaults being a Raspberry in Linux. It includes a full Python distribution, and Python is the recommended language for user programming. Used in its basic configuration, it can be treated like any other computer, and indeed, if mounted in a suitable case with monitor, mouse, and keyboard connected, it functions just like any other Linux-powered PC, albeit with modest computing resources. If used as a control system for a custom project, the programming environment may well involve using some of the peripherals access techniques, especially PyUSB for access to the built-in USB ports. can find a Raspberry Pi homepage at raspberrypi.org. There's a free community online magazine called the Magpie, where enthusiasts can share experiences, tips, and projects. In addition, several books on the subject have been published, as well as regular conferences and local user groups. Then we have the Arduino. The Arduino products are in many ways complementary to the Raspberry Pi, where the Raspberry Pi aims to teach about computing and programming. Arduino is more directly aimed at the electronics enthusiasts. It enables experimentation with interfaces, both analog and digital. The various microcontroller circuit boards in the Arduino range come in various configurations of inputs and outputs. Typically, they include a USB interface, several analog input pins, as well as digital I/O pins, thus enabling the users to interact with various external devices. Accessories are also available to extend the types of devices that can be connected. Also included is a code library called Wiring, written in C, that provides access to the various ports. There is an IDE that helps users write their code and provides a single-click mechanism to upload it to the board. The Arduino homepage is arduino.cc. Although the Arduino processor normally has to have binary application downloaded, it can also be controlled by connecting the Arduino to a controlling computer, such as a Raspberry Pi. This enables Python to be used to send instructions to the Arduino board via the USB or serial ports. There is a library to facilitate this called PyFormata, which is available from PyPy. There is a web page that discusses this further with several examples of what is possible. So just Google for Arduino interfacing Python. And there are other options as well. The popularity of the Raspberry Pi and Arduino projects has spawned several competing products. Many of these are simply low-cost clones of other projects, especially the Arduino, but others are genuine alternatives with a slightly different set of objectives or presentation of the ideas. For example, creating the smallest board possible. In most cases, Python can be used to access the boards over a serial link or even by a network connection using standard Python modules. So your favorite search engine should find many candidates. You should check the nature of the interface provided and how the programming is done. And some Arduino clones require you to program the chip on a genuine Arduino and then transfer it to the clone board for installation in the final device.